Okay, so we're going to look at the Chapter 7 quiz that you guys took. And I'm just going to kind of go through it here. So let's see what we got here. So a couple things we know. We know that the 8th term is 60 and the 12th term is 48. So we are going to need to write a system of equations. So I'm going to say, I'm going to write a for the 8th term, then I'll write an equation for the 12th term. So the 8th term is, so its sum is 60, and we find that by taking the first term plus n minus 1 times the common difference. Now remember, n in this case, right, n in this case is 8. So I'm going to replace the n with 8, and we don't know the common difference. Okay, from there, just a quick reminder before I continue. For arithmetic, reminder, your formula is first term plus n minus 1 times d. So when I went and found the 8th term, right, I subbed in 60 for my 8th term. I don't know what the first is. I plugged in 8 for n, and I don't know what the common difference is. I'm going to do the same thing for the 12th term. So for the 12th term, what do we got here? So the 12th term is 48 equals the first term plus, in this case, n is 12, so 12 minus 1 times d. From here on out, we have a system of equations. That's all we're doing, is we're just going to be solving this system. So let's see what we got here. I'm going to clean things up a little bit. So the first equation can be written like this, and the second equation can be written like this. From here, I've got a couple choices. I think what I'm going to do is I'm going to use elimination. So I'm going to subtract bottom equation from top. I'm just going to kind of do that over to the right because I'm running out of room here. So 60 minus 48 is 12. And that's, the A1s are going to cancel out. So A1 minus A1 is 0. 7 minus 11D, 7D minus 11D is negative 4D. So D in this case equals negative 3. That's great. So I now know what the common difference is. Now I got to go figure out what the first term is. So I'm going to, again, grab one of my original equations. So I'm going to go back to blue. So I'm going to go back to that 8th term. So for our 8th term, right, what we said was 60 equals our first term, which we still don't know what it is, plus n minus 1. N in this case is 8, so 8 minus 1 times d. Now we know what d is. So this is going to become 60 equals the first term, plus this is going to be 7 times negative 3. So 60 equals the first term, minus 21. So it looks like, what is that? Looks like 81 equals the first term. From there, I'm going to move some of this over. I probably need to make a little more space on this. So let's move this over a little bit. Okay, let's write our equation. So our equation is going to be, man, I'm running out of room. So a to the n equals our first term, which is 81, plus n minus 1 times d, which is negative 3. That is real mess, isn't it? I don't know if I can do a better job. Let me see if I can do a little bit better job of it. That's kind of a real mess. I am going to move things over. Okay, so a to the n equals our first term, which is 81, plus n minus 1 times our common difference, which is negative 3. From there, I can clean it up. So this is going to be 81 minus 3n plus 3. So a to the n equals 84 minus 3n. Okay? So this is our equation. From there, I'm going to use the equation I just found. So let's bring that on down. I'm going to use this equation to evaluate the 20th term. So the 20th term, all we do is we plug 20 in for n. So in this case, it looks like I get 84 minus 60, which is 24. So the 20th term is 24. Okay, let's keep on going. For the next one, we're going to write this series. We're going to write the series in summation notation. So the first thing we need to do is figure out what's going on here. So see if you agree with me. Looks like I'm adding 5 each time. So this must be arithmetic. So what do we know? We know the first term is 2, and we know the common difference is 5. So using our formula, a to the n equals the first term plus n minus 1 times d. I'm going to replace the first term and d with 2 and 5. So I get a to the n equals the first term, which is 2, plus n minus 1 times d, which was 5. From there, I can just clean it up. What do we got here? Sorry, I can't add 2 and negative 5. So I get negative 3 plus 5n. Now, that's giving me the rule, but it's asking us to write the series. It's asking us to write the series. So remember our series, I'm going to do this. I'm going to write the series right here. So our series is, you can keep this in terms of n, as we've talked about. I'm going to switch over to i's. So I'm going to start with I equals 1, and our formula is negative 3 plus 5i. Now remember, the only thing we also have to do is we have to figure out what term does this end on. And the way we do that is we take our sequence formula and we plug in 147 for a to the n, and we solve. So it looks like, in this case, we're going to get n equals 30. So this right here is our summation notation for this. Next thing it asks us to do is find the sum of the series. So remember, in order to find the sum of the series, so let's get our sum formula down. Our sum of our series is, it's going to be the number of terms times the first term plus the last term divided by 2. So in this case, our sum equals, well, our number of terms in this case is 30. Our first term, we said, was 2. Our last term is also given. It's 147. We're going to take that whole thing and divide it by 2. When you're finished, your sum is going to be this. Okay, let's keep on going. We were asked to evaluate this. Now remember, this one is starting at 5 and ending at 8. We can't use a formula here. So all I'm going to do is I'm just going to say this is 2 times 5 squared plus 3. That's the first term in the sequence. I'm going to add to that 2 times 6 squared plus 3. I'm going to add to that 2 times 7 squared plus 3. And then I'm going to add to that, I'm going to go down here because I'm running out of room a little bit. So 2 times 8 squared plus 3. From there, I'm just going to grab my calculator and get my total. So in this case, I get 360. So again, I had to directly plug because this did not start at 1. Okay, let's look at this one. We are told this is a geometric sequence, and we're supposed to write a rule. So remember, for our geometric sequence, our formula is first term times r to the n minus 1. So I need a couple things. I think you'd agree the first term is pretty clearly 80. R, remember, in order to find r, you take 2 consecutive terms, take the second divided by the first. So 40 divided by 80 is 1/2. I'll double check it. 20 divided by 40 is 1/2. 10 divided by 20 is 1/2. So absolutely, this is geometric, even though they told us, right? So it was never a bad idea to check. But again, they told us it was geometric, so we only really need to do one pair. From there, we're going to get a to the n equals our first term times 1/2 raised to the n minus 1. Now we're asked to find the sum of the first 12 terms. So remember, our sum formula is going to be the first term times 1 minus r to the n over 1 minus r. And that's for a geometric, finite geometric sequence, right? Where there's a specified number of terms. So in this case, we're going to get our first term was 80, and we're going to get 1 minus r. R is 1/2 raised to, in this case, we were asked to find the first 12 terms, so raised to the power of 12 over 1 minus r. From there, we're just going to grab our calculators, and we get 159.96. Okay, last one. We are asked to do, again, a geometric sequence, and we know the fourth term. So the fourth term, in this case, what do we got? So we got 144 equals our first term, which we don't know what it is, times r, which we do know, to the n minus 1, where n is 4. So 4 minus 1. From there, I'm just going to solve this for the first term. I should be able to do that. So in this case, I'm going to get the first term equals 144 divided by 27, which reduces to 16 thirds or 5.33. So I'm just going to write 16 thirds. From there, we are ready to write our sequence. So our sequence is a to the n equals the first term, whoops, I'm writing the first term, equals 16 thirds times our common ratio, which is 3, raised to the power of n minus 1.